Good day, viewers. Welcome to another edition of Subject Math. Today we'll be talking about differentiation, and under differentiation, we'll be starting off with differentiation of algebraic functions. So when I say differentiation of algebraic functions, what do we get to think of? Algebra is this branch of mathematics that deals with what? Alphabet and numbers. So let's say y here is equal to what? Ax raised to the power n. Now, what you have here is an what? Algebraic function, and you have to differentiate this particular algebraic function. What do you get to do? So you say the y, the x of this particular function, this n power has to come down to be n multiplied by ax raised to the power n minus 1. If you take this particular step, this is your method of what? Differentiation. Let's take y here is equal to 5x raised to the power 3, and you are asked to find dy dx. Looking for your differentiation here, find dy dx. Now, your power here, you bring it down, this becomes that dy dx is equal to 3 times 5 x raised to the power 3 minus 1. 3 times 5 here gives us 15 x raised to 3 minus 1 here gives us 2. Now this is simply your differentiation. So if you have that y is equal to 6 over x, I am asked to find dy dx. With this is positive reciprocal, so you have to compare this positive reciprocal to what? To negative reciprocal. This becomes that y here is equal to 6x raised to the power minus 1. How did this become minus 1? Because this negative guy came up here. Coming up here, it turns to what? Minus 1. So differentiating this, dy dx here is equal to minus 1 comes down as minus 1 times 6x raised to the power minus 1 minus 1. That's equal to minus 1 times 6 will give you what? Minus 6 x raised to the power minus 2. So you can express this guy in positive reciprocal, which becomes that dy dx is equal to 6 over x raised to the power 2. With this here, we'll arrive at our final answer. Now, from there we have a question here. This says that t is equal to 3 over x raised to the power 6. Find the t dx. Now what are we doing? We're differentiating t in respect to x. So t here is equal to 3x raised to the power minus 6, which is a negative reciprocal. Then what? The t dx here is equal to minus 6 times 3 x raised to the power what? Minus 6 minus 1, which is equal to minus 18x raised to the power minus 7, which is now equal to your dt dx here is now equal to minus 18 all over x raised to the power 7. Now, looking at this, you have a negative reciprocal here, so your dy dx here is equal to minus 3 over 2 x raised to the power minus 3 over 2 minus 1. So this is now minus 3 over 2 x raised to the power. You look for your LCM here. Your LCM is 2. 2 divided by 2, 1. 1 times that. Minus 3 minus 2 divided by 1, 2. 2 times this guy, 2. So this is minus 3 over 2 x raised to the power minus 3 minus that's minus 5 over 2. With this is negative reciprocal. You have to bring it down to the positive reciprocal. This becomes minus 3 over 2 times 1 over x raised to the power 5 over 2, which is now equal to 1 minus 3 times 1. That's minus 3 over 2 x raised to the power 5 over 2. So you can now express this as minus 3 over 2 square root of x raised to the power 5. Now this is the solution to this particular question. Now we have a question here which says if y here is equal to this, then what? Find dy dx as s is equal to minus 2. What is this question trying to say? They say we should find dy dx that after differentiating, we put our x for minus 2. So this becomes that here dy dx is equal to, differentiate this, this is what, 9x raised to the power 2 plus differentiate this, this is what, 2x plus, if you differentiate a constant you will get 0. Why is it 0? Let me explain why this is 0. Why this is 0? So this is 6 what? Differentiating 6, then you add here x raised to the power 0. X raised to the power 0 is 1. So 6 times 1 is what? 6. So differentiate this guy. This is 0 times 6 x raised to the power 0 minus 1. So 0 times any number here will give us 0. That is why whenever you differentiate the constant, you get 0. So here, dy dx here is equal to 9x squared plus 2x. So they say what? If x is equal to minus 2. So what happens here? This is that what? 9 times what? Minus 2 raised to the power 2 plus what? 2 times what? Minus 2. So with this here, this is now what? 9 times what? Minus 2 squared, that's 4 plus what? Plus what? 2 times minus 2, that will give us what? Minus 4. Okay, so 9 times 4, which will give us 36 minus 4, which is equal to 32. Now, so having 32 in this particular question, we can now what? Go further to what? Solving this particular question. So this question said find derivative of f of x is equal to what? 2x open bracket x squared plus what? 3. So f prime of x here, okay, before we go to our x prime of x, we can expand such that f of x here is equal to, this guy times this is 2x raised to the power 3 plus this times this is what? 6x. So we can now what? Differentiate f prime of x here is equal to, this guy comes down as 6x raised to the power 2 plus 6. So you can factorize that f prime of x is equal to 6 open bracket x squared plus 1, and you have this here as your final answer. Now we have what? Our special derivatives. Now these special derivatives simply means what? Whenever we differentiate a particular function, we get this dy dx. So if we differentiate in x, we get 1 over x. If we differentiate exponential x, we also get what? Exponential x. Now whatever thing we differentiate here, we're going to get this. So if we differentiate sine x, we get cos x. If we differentiate cos x, we get minus sine x. If we differentiate tan x, we get sec square x. If you differentiate cot x, you get minus cosec square x. If you differentiate sec x, you get sec x tan x. If you differentiate cosec x, you get what? Minus cosec x cot x. So this is cot. If you differentiate cot x, you get minus what? Cosec square. Now look at this question from JAM 1995. So the question said what? Find the derivative of cosec x. Find the derivative of cosec x. So with this, dy dx of cosec x. Now if you have cosec here, if I differentiate by cosec, what would I get? I'll get what? Minus cosec x tan x. And this is the derivative of cosec x. Now we go further to what we call the techniques of differentiation. Now this technique simply means what? Ways of how we want to solve problems on differentiation. Now so there are different ways or different techniques of solving what? Problems under differentiation. So one of these ways are the chain rule. Now this chain rule, you can call it what? The function of a function. Now this chain rule is very, very important. I'll explain further when I start. We have the product rule, where you have what? Product of two different functions. I will have the what? Quotient rule, where you have what? Division of two different functions. Now, kicking off with what? Chain rule. Kicking off with what? Chain rule. Now, why do we use chain rule? We use chain rule when the power of a particular function is very, very what? High. So you use chain rule to make your what? Your solution easier. I'm going to explain the steps by which we use chain rule to solve our problems. So moving ahead with an example in chain rule, now look at this question. If y here is equal to 2x plus 1, all in bracket raised to power 3, find dy dx. So in this kind of question, what do you say here? You make an assumption. Let the content of this bracket, that is what? 2x plus 1 be u. Therefore, this now u here is equal to 2x plus 1. Differentiate. Du dx here is equal to what? Du dx here is equal to what? 2. With this, y here is not equal to, this guy is no longer 2x plus 1. This is now what? U raised to power 3. Differentiate. Dy du is equal to what? 3u raised to power 2. So with this development, you can now find your what? Your using chain rule. That dy dx is equal to du dx times dy du. Now with this, what's your du dx? That is what? 2 times what? 3u raised to power 2, which is equal to what? 6u raised to power 2. What's the value of u? That is what? 6 open bracket 2x plus 1 all raised to power 3. With this, we have arrived at our final answer. So having a question here from JAMB 2009, question number 36, it says that here y here is equal to 3 cos 4x. Find dy dx. So you say let 4x be equal to u. So with this is now what? U is equal to 4x as du dx is equal to 4. So this is now y here is equal to 3 cos u. So dy du here is equal to what? If you differentiate cos, you get minus sine. That is what? Minus 3 sine u. So with this development, your dy dx is equal to du dx times dy du. What's your du dx? Which is 4 times dy du, which is what? Minus 3 sine u. 4 times minus, that's minus 12 sine u. What's your value of u? Your value of u here is what? 4s. So that's minus 12 sine 4x. So with this, it moves us on answer minus 12 sine 4x. So we have a question here. Differentiate this in respect to what? X. So you say let u here be equal to x raised to power 2 minus 1 over x. So differentiate, this becomes du dx is equal to 2x raised to power what? Minus what? Okay, plus 1 over x raised to power 2. This is your du dx. How did I get this? If I'm explaining further or explaining better, if I differentiate this guy, 1 over this becomes what? X raised to power minus 1. Differentiating this becomes minus 1 what? X raised to power what? Minus 1 minus 1. That's equals to minus x raised to power minus 2, which is positive reciprocal is equal to minus 1 over x raised to power 2. So bringing it here, minus times minus, that's plus. Now we have what? This guy. So since we differentiated this, what are we having next? What are we having next that what? Y here is equal to u raised to power what? 2. So dy du here is equal to 2u. So with this, dy dx here is equal to what? Du dx multiplied by what? Dy du. Du dx give us this long guy. That's 2x plus 1 over x raised to power 2 in brackets times what? 2 times what? U. What's our value of u? Our value of u here is what? X squared minus 1 over x. So we can now what? Expand this. This is now what? 2 open bracket. This guy times this guy. This guy times this is now what? 2x raised to power 3 minus what? 2x over x. This guy times that plus what? S square over s square minus what? 1 over s raised to power 3. So with this can cancel this. This is now equal to what? 2 open bracket what? 2s raised to power 3 minus 2. This can cancel this. Plus 1 minus 1 over x raised to power 3. So with this, we can now proceed. Okay, I'm wiping off this end. We can now proceed to this now give us what? 2 open bracket 2s raised to power 3 minus 2 plus 1 will give us what? Minus 1 minus 1 minus 1 over s raised to power 3. So at this junction, you can leave this here as your final answer. Or you can go forward. If you want to go forward, that's what making this guy LCM. That's 2 open brackets. Your LCM is s raised to power 3. So this becomes what? 2s raised to power what? 6 minus s raised to power 3 minus 1. Now this determines what is in your what? Your option. So with this, we're going to stop here to move to the next question. Here, so we're having what is an exercise already. So having this exercise, it says that if y here is equal to this, differentiate. So after solving this particular exercise, this is going to be your final answer. So we have this exercise here too. If y is equal to this, so having this here, this is raised to power 4. If we differentiate this is going to be our final answer. So I'd like us to attend these 2 questions to see what our outcome will be like. So with this, we move to the next technique of differentiation, which is what we call the product rule. We call it the product rule because we are having to do with what? The combination of 2 different functions, u and v. Having u and v here, your dy dx of this particular function here is equal to u, if you hold this u, you differentiate this, that is dv over dx, plus you hold your v, differentiate your u, that is du dx. Now this here is the formula for solving any what? Product rule question. So let us take 1 or 2 questions to back up what we are trying to say here. So it says that if y is equal to s sin x, if y is equal to s sin s and dy dx is equal to pi over 2, or rather find dy dx when x is equal to pi over 2. Now look at this IVT question. So what happens here? You differentiate. How do you differentiate? This here is your u, while this here is your v. And I told you use this formula. dy dx is equal to u to v dx plus what? V du dx. So we'll take our u. What is our u? Our u here is what? Our u here is what? S. If you differentiate sin s, what will you get? You get cos s plus, you hold your v. What's your v? Sin x. If you differentiate sin x, if you differentiate x, what will you get? You get what? 1. So dy dx here is equal to s cos s plus what? Sin x times 1 is going to give you what? Sin x. But now we're not going to stop here. We're not stopping here because the question says what? Find your dy dx when pi is equal to what? So when s is equal to pi over 2. Therefore, if s is equal to what? Pi over 2. This pi over 2 is in radii, and you can convert from radii to a degree. That is what? Pi over 2 multiplied by what? 180 over pi. Such that pi cancel pi, 2 here 1, 2 here what? 90. So your pi over 2 is equal to what? 90 degrees. So dy dx here is equal to 90 open bracket what? Cos 90 plus what? Sin 90. Cos 90 will give us what? 0. 0 times 90, that's equal to 0 plus sin 90 will give us what? 1. So your dy dx here is equal to 0 plus 1 here will give us the value 1. Here, having solved this question, if y here is equal to what? This and what? This, and you're asked to what? Differentiate. So this is a product of two functions. We are going to solve this question under what? Product rule. So don't forget your product rule here says dy dx is equal to what? U to v plus v du. So what is our u in this question? This is our u here. That's what? X plus 1. The v here is differentiate. Differentiate we get 1 plus what is our v? That is what? S plus 2. If we differentiate this, we get what? 1. So, expanding this times this, that's what? S plus 1 plus what? This times this, that is what? S plus what? 2. So, with this is not equal to what? 2s plus 3, and that is our final answer. So, here we are having what? Exercise 3 questions under product rule. We have this: if what y is equal to this, find your dy dx. We have the options and we have our final answer here. This one says that if what, find derivative of what, this guy, I'll have our answer here. And this one says find derivative of what, the function. This is the function here. I'll have our option. They say what? It's an IVT question. They say what? And the point x here is equal to what? 1. This is very important. And this is our answer. Yeah, so please try as much as you can to what? Attempt the questions to be able to know what your progress is like. Here, we have a question here which says the slope of a tangent to the curve y is equal to y is equal to 3x squared minus 2x plus 5 at the point 1, 6. So what is your dy dx? Your dy dx here is equal to 6x minus 2. Now they ask us what? To find the slope, which is your dy dx at this point. What is the point? The point here in Cartesian form is 1, 6, where this is your x, this is your y. So you put your value of x into the equation. This becomes like your y ds, which is your slope here, is equal to 6 open bracket 1 minus 2. 6 times 1 is 6 minus 2. And 6 minus 2 here gives you 4. That makes what? C our answer to this question. Here, this GC question 1995, question number 2 said, find the differential coefficients of the function. What is your function? Y here is equal to 1 over x squared plus 9. This function can be represented as y here is equal to x squared plus 9 raised to the power minus 1. So with this you can use quotient rule to solve. So we'll evaluate. So your dy dx here, using your quotient rule, you bring down your power, that is minus 1, open bracket, you differentiate this guy, this is then what? 2x, rewrite this guy, x squared plus 9, subtract 1 from the power, minus 1 minus 1. This is equal to minus 2x open bracket, x squared plus 9 raised to the power what? Minus 2. You can now write this as positive coefficient, that's minus 2x over x squared plus 9 raised to power 2. Now we'll have the point, given the point 4 comma what 1 over 25. So your value here is what x, put x into this. So this becomes that your dy dx here is equal to minus 2 times 4 all over 2 square, sorry not 2 square, 4 square plus what 9 raised to power 2. Minus 2, that is equal to minus 8 over 4 square, that's 16, 16 plus 9, that's what 25 raised to power 2. So this is equal to what? Minus 8 over 25 raised to power 2, that was going to give you 625. So your answer to this particular question, or the differential coefficient of this function here, is minus 8 over 625. Now, find the gradient on the curve, which says, okay, this, we're having here y raised to power. So this question here says y here is equal to x raised to power 3 plus 6x raised to power 2 minus 15x plus 1. So differentiate. So your dy dx here is equal to 3x raised to power 2 plus 12x minus 15. Now they say that what your gradient is equal to 0. So 0 here is equal to 3x squared plus 12x minus 15. This is a reducible quadratic equation, so reduce all through by 3. So 0 here is equal to x squared plus 4x minus 5. Okay, having this now, let's factorize. So this is x squared plus 5x minus x minus 5 is equal to 0. So factorizing for that, this is now what? X open bracket x plus 5 minus 1 open bracket x plus 5 is equal to 0. So x minus 1 in bracket what? X plus 5 is equal to 0. So x here is equal to 1, or x here is equal to minus 5. So having this now, since we have a value of x and what? X1 and x2. So we come here and say what? Y here from the question says what? X raised to power 3 plus what? 6x squared minus 15x plus 1. So when what? X is equal to 1, you put your 1 here, this will come down. Y here is equal to 1 raised to power 3 plus 6 open bracket 1 squared minus 15, 1 plus 1. So your y here is equal to 1 plus what? 6 minus 15 plus 1. That will going to give 6 plus 1, 7, plus 1, 8. 8 minus 16, that will give us what? Minus 7. So when what? X is equal to what? Minus 5. So y here is equal to minus 5 raised to power 3 plus 6 times minus 5 minus 15 times what? Minus 5 minus 15 times minus 5 plus 1. So y here is equal to what? Minus 125 minus what? 30 plus 15 times this, that is 75 plus 1. So adding this up, this is going to give us, now I'd like us to pay attention to this. Please, there's a square here, there's a square here, so which becomes what? Minus 5 raised to power 2, that's 25. 25 times 6, that's going to give us what? 150 plus what? 7 plus 150 plus 75 plus 1. So adding everything here will give us what? 130. 1. So at this junction, you can now make a conclusion. X is equal to, okay, let's say what? X comma y, this is now equal to 1 comma what? Minus 7 and what? Minus 5 comma 101. So what? This is the answer to this particular question. Here we're having what? Some exercise. The gradient on the curve exercise. To attempt this, and this is our answer, our A. I will have this question to attempt it, and this is our answer B. So attempt the questions to know your progress.